Howdy. Um, I just wanted to share this conversation of those two guys because I think it's very interesting. Lex seems to be relaxed today, and I just wait for this. I have forgotten his name. Yeah, it doesn't tell it. But anyway, Michael Levin. I just wait until Michael Levin probably appears in the Thunderbolts video. But anyway, let's have a listen to that. That is something very interesting.
Can you actually step back? We'll return to it. What is bioelectricity? What is biochemistry? What are electrical networks? I think a lot of the biology community focuses on the chemicals as the signaling mechanisms that make the whole thing work. You have, I think, to a large degree, uniquely, maybe you can correct me on that, have focused on the bioelectricity, which is using electricity for signaling. There's also probably mechanical,
Sure,
like
biomechanical.
knocking on the door. So what's the difference, and what's an electrical network?
Yeah. So I want to make sure and kind of give credit where credit is due. So as far back as 1903 and probably late 1800s already, people were thinking about the importance of electrical phenomena in life. So I'm for sure not the first person to stress the importance of electricity. There were waves of research in the 30s, in the 40s, and then again in the kind of 70s, 80s, and 90s of sort of the pioneers of bioelectricity who did some amazing work on all this. I think what we've done that's new is to step away from this idea that, and I'll describe what the bioelectricity is step away from the idea that, well, here's another piece of physics that you need to keep track of to understand physiology and development, and to really start looking at this as saying, no, this is a privileged computational layer that gives you access to the actual cognition of the tissue, of basal cognition. So merging that developmental biophysics with ideas in cognition of computation and so on. I think that's what we've done that's new. But people have been talking about bioelectricity for a really long time, and so I'll define that. So what happens is that if you have a single cell has a membrane. In that membrane are proteins called ion channels, and those proteins allow charged molecules, potassium, sodium, chloride, to go in and out under certain circumstances. And when
Sorry for interrupting, but when I heard this the first time, just what he said about potassium and stuff, I had to think about wide rivers. There might be hints in for geological for understanding geology in this talk. But anyway, let's give it still a few seconds.
there's an imbalance of those ions, there becomes a voltage gradient across that membrane. And so all living cells try to hold a particular kind of voltage difference across the membrane, and they spend a lot of energy to do so. When you so that's a single cell. When you have multiple cells, the cells sitting next to each other, they can communicate their voltage state to each other via a number of different ways, but one of them is this thing called a gap junction, which is basically like a little submarine hatch that just kind of docks, right? And the ions from one side can flow to the other side and vice versa. So
Isn't it incredible that this evolved? Isn't that wild? Because that didn't exist.
correct, this had to be evolved, and
It had to be invented.
That's right.
Somebody invented electricity in the ocean. When did this get invented?
Yeah. So I mean, it is incredible. The guy who discovered gap junctions, Werner Lowenstein, I visited him. He was really old.
A human being.
He discovered them.
Because you know what? Because who really discovered them lived probably 4 billion years ago.
Good point.
So you're give credit where credit is due. I'm just saying.
He rediscovered gap junctions. But when I visited him in Woods Hole maybe 20 years ago now, he told me that he was writing, and unfortunately he passed away, and I think this book never got written. He was writing a book on gap junctions and consciousness, and I think it would have been an incredible book because gap junctions are magic. I'll explain why in a minute. What happens is that, just imagine, the thing about both these ion channels and these gap junctions is that many of them are themselves voltage sensitive. So that's a voltage sensitive current conductance. That's a transistor. And as soon as you've invented one, immediately you now get access to, from this Platonic space of mathematical truths, you get access to all of the cool things that transistors do. So now when you have a network of cells, not only do they talk to each other, but they can send messages to each other, and the differences of voltage can propagate. Now, to neuroscientists, this is old hat because you see this in the brain, right? There's action potentials, the electricity. They have these awesome movies where you can take a zebra, like a transparent animal like a zebrafish. You can literally look down and you can see all the firings as the fish is like making decisions about what to eat and things like this, right? It's amazing. Well, your whole body is doing that all the time, just much slower. So there are very few things that neurons do that all the cells in your body don't do. They all do very similar things, just on a much slower time scale. And whereas your brain is thinking about how to solve problems in three-dimensional space, the cells in an embryo are thinking about how to solve problems in anatomical space. They're trying to have memories like, hey, how many fingers are we supposed to have? Well, how many do we have now? What do we do to get from here to there? That's the kind of problems they're thinking about. And the reason that gap junctions are magic is, imagine, right, from the earliest time. Here are two cells. This cell, how can they communicate? Well, the simple version is this cell could send a chemical signal. It floats over and it hits a receptor on this cell, right? Because it comes from outside, this cell can very easily tell that came from outside. It's whatever information is coming. That's not my information. That information is coming from the outside. So I can trust it. I can ignore it. I can do various things with it, whatever. But I know it comes from the outside. Now imagine instead that you have two cells with a gap junction between them. Something happens. Let's say this cell gets poked. There's a calcium spike. The calcium spike or whatever small molecule signal propagates through the gap junction to this cell. There's no ownership metadata on that signal. This cell does not know now that it came from outside, because it looks exactly like its own memories would have looked like of whatever had happened, right? So gap junctions, to some extent, wipe ownership information on data, which means that if you and I are sharing memories and we can't quite tell who the memories belong to, that's the beginning of a mind meld. That's the beginning of a scale up of cognition from here's me and here's you to no, now there's just us.
So they enforce a collective intelligence.
That's right.
So you can scale this up, like to planetary size. How, like, Earth is a living organism. We are part of this living organism. We are connected through electric currents to the sun, and the sun is connected to our galaxy. And our galaxy is connected to other galaxies. And you can really scale it down from the atomic size to cosmical size. The same principles, different ingredients, different densities, different waves, or wave heights and lengths, bad and good weather. But anyway, I just wanted to share because I thought that's something interesting. Thanks. Bye.